Well, let's take a look at trig integrals. Now, the idea behind these go like this. First, let me write down our derivatives. The derivative of sine is equal to cosine. The derivative of cosine is equal to negative sine. Derivative of tangent is equal to secant squared. Your derivative of cotangent is equal to negative cosecant squared. And the derivative of secant is equal to secant tangent. And last, the derivative of cosecant is equal to negative cosecant cotangent. Now, the idea behind most of the problems in this section are you'll have an integral, and you're going to have one of these trig functions to a power. Now, if we have sine, for example, inside the parentheses, then our u would be sine, and our derivative would be cosine. So what we're going to want is to, over here, we're going to want to save a cosine. We'll see more about what that means here in a little bit, but because we need a cosine for the u substitution. And then the idea, this isn't true 100% of the time, because kind of every problem's kind of different, but the idea is you convert the rest to sines. So everything else is in sines, and you save one cosine. Or you'll have cosine to a power, and you'll save a sine, because the derivative of that is negative sine. The negative's trivial, but we need a sine. And then we'll convert the rest to cosines. You'll have maybe a tangent to a power, and if you have tangent to a power, you have to have secant squared for the u substitution. So you'll save a secant squared, and you'll convert the rest to tangents. And this one, we'll have cotangent to a power. We need to save a cosecant squared. Again, the negative is trivial. We can always put a negative inside of an integral. And convert the rest to cotangent. On this one, we have secant to a power. Now we'll need to save a secant tangent, because you need that for your u substitution. And we convert the rest to secants. Okay, so this one will have cosecant to a power, and we'll need to save cosecant x, cotangent x, and then convert the rest to cosecants. Now that's a general idea. We're going to see some of these have a little bit different twist to them and so forth, but we're going to go with that. Let's look at our first problem. We've got the integral of cosine of the third sine squared x dx. Okay. We come up here. It's either going to be this first type or this second type. I guess I ought to put numbers on those. That might actually help, right? That's our first type, second type, third type, fourth type, fifth type, or sixth type. Well, it's either this one or this one. Now, specifically, for this one we need to save a cosine. This one we need to save a sine. Well, if I saved a sine, that would just leave me one sine, and we always got to have a even power. But if I come over here to the cosine of the third, if I save one of those cosines off, we'll have an even power, and we'll see why that is. So we're going to save a cosine. So that's going to be type 1. So save a cosine, convert everything else to sines. And what am I doing? Okay, it's down below this. Okay, so I'm going to rewrite this as cosine squared, sine squared, cosine, dx. Now this right here is going to be the part we'll save. And I'll just put a double line underneath it to indicate save. But we can't touch that. And I really need to save this in a PDF. Let me go ahead and do that. There we go. And I'll bring that up. This is what we're going to refer to. Okay, so we've saved our cosine. Now we want to convert everything else to sines. Well, recall we got sine squared plus cosine squared is equal to 1. We just said we want to convert the rest to sines. So over here, I need to get rid of this cosine squared. This is one I'm working on to get rid of. Well, over here, if I take the sine squared to the right side, then cosine squared is going to equal to 1 minus sine squared. So this problem here, I can rewrite cosine squared as 1 minus sine squared. And everything else carries down. Again, the blue indicates that's the part we're saving. Well, then I can multiply this through. So it's kind of like I'm taking these two items here and multiplying it times the 1 and times the negative sine squared. So sine squared cosine times 1 gives us sine squared cosine. And sine squared cosine times this gives us minus sine to the fourth x cosine x dx. So I'll multiply that through. Now I'm going to split these into separate integrals. So this one is sine squared cosine dx minus sine to the fourth cosine dx. I didn't do that in blue, did I? And this is our save, 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 and save. So now I'm going to rewrite this as sine x to the second power cosine x dx minus, and then this one will be sine x to the fourth power cosine x dx. Now both of these would use the same u substitution, so I'm going to share them. We'll always let u equal to what's inside of parentheses, so u is equal to sine x. The derivative of sine is going to give us cosine, and then we add on our dx. Well, both of these have cosine dx, so that's perfect. So this one becomes u squared du minus, and this one becomes u to the fourth du. Add 1 to our power, divide by our new power, so it becomes 1/3 u to the third minus, add 1 to our power, divide by our new power, 1/5 u to the fifth, plus c. And u, we said, was sine x. So let's put that in there. So we've got 1/3 sine to the third minus 1/5 sine to the fifth plus c. And that's our answer. I guess I need to save that page. And this is Trig Integrals. So Calc 2 Trig Integrals, page 01. And let's look at our next problem. Okay, so we got cosine of the third. And then dx. Well, there's really no question on this one what to save. The only thing we can save is a cosine. So we're going to rewrite this as cosine squared times cosine. Now, after we've separated them into our saved part versus our non-saved part, this has to be an even power. The only way this can be converted to the other trig function is if it's even. Now, if I come over here, we saved a cosine, it says convert the rest to sines. We've already indicated that cosine squared is equal to, cosine squared is equal to 1 minus sine squared. And cosine x there, and again, that's our save. Now this is like the distributive property. We're going to take this and multiply it times the 1 and times the negative sine squared. Well, cosine times 1 gives us cosine, and I'm going to split these into separate integrals while I'm doing that. Minus cosine times negative sine, I put negative out in front, and we got sine squared cosine dx. Now the cosine x is straightforward. The integral of cosine gives us sine. Then on this one, I'm going to rewrite it a little bit. I'll rewrite it as sine to the second power cosine x dx. Again, that's our saved part. So now, if I let u equal to what's inside the parentheses, so u is equal to sine x, du will equal to cosine x dx. So this becomes sine x minus the integral of u squared du. Add 1 to our power, divide by our new power, so we get minus 1/3 u to the third. Put my plus c on. And u we said was sine x, so this becomes minus 1/3 sine to the third plus c. And that's our answer. And, let's look at our next problem. I don't know if I have room for that next one. Hate to put each one of these on their own separate page, but so I'll have a ton of pages then. But okay. So this problem, we got the integral of sine to the fifth over cube root of cosine x. Well, this one right here, cube root of cosine x. Well, how in the world would I ever save cosine of that? Because that's like cosine to the 1/3 power. I can't. So obviously I'm going to save one of these signs up here. And if I take one of those signs away, it takes it to the 4th power, so it works out nice. And I'll eventually find it. There it is. So we're going to save a sign. So we're working with form 2 here. And then we'll convert the rest to cosines. Okay. So I'm going to rewrite this. This is sine to the 4th. And while I'm at it, I'm going to go ahead and rewrite this as cosine to the 1/3 power. And we're going to save a sign. Like that. So again, we're not going to touch this one. That's saved. And we want to convert all the rest to cosines. Well, sine to the 4th is sine squared times sine squared. X dx. And sine squared is 1 minus cosine squared. Like that. And then this is still cosine to the 1/3 power. And here's our sine. Again, that's saved. I'm not going to touch that. I'm getting closer. Everything's in terms of cosine, but let's multiply these together. 1 times 1 is 1. 1 times negative cosine squared is negative cosine squared. Negative cosine squared times 1 is negative cosine squared. Negative times a negative is positive, and cosine squared times cosine squared gives us cosine to the 4th. Over cosine to the 1/3 power sine x dx. Okay. So then this becomes 1 minus 2 cosine squared. Combined together, these are alike. Plus cosine to the 4th over cosine x to the 1/3 power sine x dx. Now I got a single item down here and multiple items up on top. So I'm going to put each item on top, items separated by pluses and minuses. I'll put each item on top over this. So I'm going to have 1 over cosine x to the 1/3 minus 2, and this is cosine x to the 2nd power. Like that. And this one will be cosine x to the 4th power over cosine x to the 1/3. And I still have my sine x over here that I've saved. Like that. Okay. Well, this one right here I could rewrite as cosine x to the negative 1/3. If you have something to a power down in the denominator, you can take it up on top and the sign of the exponent changes. Minus 2, and this would be cosine x. And if you got something to a power over something to a power, and they're the same, you subtract the exponents. 2 minus 1/3 gives us 5/3. Like that. And plus, and here we're going to have cosine 4 minus 1/3. This is 12/3, so that's 11/3. And then our sine x dx. Okay. Now, and let me do that in blue. So again, that's what we just saved. Okay, so we saved a sine. We converted everything else to cosines. Well, now we're ready to do our u substitution. And it's the same u substitution on all three of these, so I'll just go ahead and merge them together. Our u would equal to cosine x. Derivative of cosine is negative sine dx. So I need a negative in there. That's easy. I'll offset it with a negative out in front. And minus 2 cosine x to the 5/3 plus cosine x to the 11/3, then negative sine x dx. Okay, so now we're ready to do our substitution. Negative stays out in front. This becomes u to the negative 1/3 minus 2u to the 5/3 plus u to the 11/3 du. Again, du replaces the negative sine x dx. So we'll add 1 to our power. So I got negative 1/3 plus 1 over negative 1/3 plus 1. Over here we'll add 1 to our power. So we got 5/3 plus 1. Divide by our new power. On this one we'll add 1 to our power. So we got 11/3 plus 1. And then divide by our new power. And plus c. Negative 1/3 plus 3 gives us 2/3. So this becomes u to the 2/3 over 2/3 minus 5/3 plus 1 gives us 8/3 over the 8/3 plus, and this becomes u 11/3 plus 1 gives us 14/3. And then we have 14/3 down there, plus c. Okay. Now we're going to do a couple of different things here, since I'm about out of space. You got a single fraction downstairs, so you flip it and multiply it times your top part. So, and I'll go ahead and take this negative and carry it through. So this becomes negative 3/2 u to the 2/3. And u, we said, was cosine x. So we're going to have cosine x to the 2/3. And then this negative makes that a positive. And we had a single fraction downstairs, so we flip it and multiply it times our top part. So that's 8 over 3, so it'll be 3 over 8. 3 over 8 times 2 gives us 6 over 8, or 3/4. And then we have u, which was cosine x, to the 8/3. And here we have a single fraction downstairs. We flip it, multiply it times the top part. This is 14 over 3, so this would be 3 over 14. And this would be cosine x to the 14/3 plus c. And that's our answer. Some of these get kind of long problems. Let me save that. And let's look at the next problem. Number 4. So I got sine squared of 7x dx. Now this one doesn't seem to fit our pattern, because if I save a sign here, then I need to convert the rest to cosines. But if I save a sign, then all I'm left with is a sign, and you have to have an even power to convert it to cosine. But we got a formula. Recall, sine squared u is equal to 1 minus cosine 2u over 2. So this right here, fitting this pattern, this would be u. And we got this formula, which means we can rewrite this as 1 minus cosine 2 times u, and u we just said was 7x, over 2 dx. That's our power reducing. Now this 2 down here is 1/2, so I can take that out in front. And we got 1 minus cosine of 14x dx. Well, if I split these into separate integrals, 1/2 times all of them. So we have 1 dx minus the integral of cosine 14x dx. Well, the integral of 1 is x minus, here we're going to do a u substitution. So we let u equal to 14x. du would be 14 dx. So that means we need 14 inside, and we offset it with a 1 over 14 out in front. Like this. So we've got 1/2 times x minus 114. And now we'll replace the 14x with u and a 14 dx with du. Well, the integral of cosine u is sine u. I'll go ahead and put the plus c here at the end. And u, we said was, what did we say u was? U is 14x. So I'll go ahead and put the 14x in here, plus c. And multiply the 1/2 through, and we get 1/2 x minus 1 over 28 sine 14x plus c. And that's our answer. And let me save that. And let's look at the next problem. There we go. Number 5. So we got the integral of cosine to the 4th power of 4x dx. Okay, now the only one that really fits is if we'd save a cosine. But if we saved a cosine, then we'd be left with cosine to the 3rd. And again, it has to be an even power for us to convert it to sines. So this one uses the power reducing formulas also. So let's put that over here. Recall cosine squared u is equal to 1 plus cosine 2u over 2. Now this one I could rewrite, because it's cosine of the 4th, it's not cosine squared, but we could rewrite it as cosine squared 4x times cosine squared 4x. And now each one of those, this would be our u, so we can rewrite it with this formula. So this one becomes 1 plus cosine 2 times u, and u was 4x, over 2. And this one is 1 plus cosine 2 times u, which was 4x, over 2 dx. Well, this is 1/2, this is 1/2, so we can bring a 1/4 out in front. And we're going to have 1 plus cosine 8x times 1 plus cosine 8x dx. Well, 1 times 1 is 1. 1 times cosine 8x is cosine 8x. Cosine 8x times 1 is cosine 8x. And cosine 8x times cosine 8x gives us cosine squared 8x. So this gives us 1 plus cosine 8x plus cosine 8x is 2 cosine 8x plus cosine squared 8x dx. Well, we've got another problem. We're left with a cosine squared, and we can't have that. So again, recall our cosine squared u is equal to 1 plus cosine 2u over 2. So in this particular one right here, this is going to be our u, 8x. This first part is 1 plus 2 cosine 8x plus, and then from this formula, that'll be 1 plus cosine 2 times u, which is 8x, all over 2 dx. So we got 1 plus 2 cosine 8x plus 1 plus cosine 16x over 2 dx. Now I'm going to split these up a little bit. These are like two separate fractions here. So we've got 1/4 and then 1 plus 2 cosine 8x plus 1/2 plus 1/2 cosine 16x dx. Well, 1 plus 1/2 gives us 3/2 plus 2 cosine 8x plus 1/2 cosine 16x dx. Now I'm going to split these into separate integrals. 1/4 times all of it. So this first one would be 3/2 dx. This next one, I'm going to take the 2 and put it out in front. So it would be 2, the integral of cosine 8x dx. This one I'll put the 1/2 out in front. So I got plus 1/2, the integral of cosine 16x dx. Well, 3/2 is easy, but this is a u substitution. So this would be our u. So du would equal to 8 dx. So we need an 8 inside. This one I'll use w. So I'll say w here. So then dw is going to equal to 16 dx. Now I'll go ahead and do this one. The integral of 3/2 is 3/2 x. Plus, I need an 8 inside, so I'll offset it with a 1 over 8 out in front. And on this next one, I need a 16 inside, so I'll offset it with a 1 over 16 out in front. Okay, so then I got 1/4, 3/2 x, plus 2 times 1/8 is 2/8 or 1/4. And here this becomes cosine u du. This one, 1/2 times 1/16 is 1/32. And this becomes the integral, and we're using w's here, but it'd be cosine w dw. Okay, so then we've got 1/4 times 3/2 x plus the integral of cosine is sine, so that's sine u plus 1 over 32, and this would be sine w, the integral of cosine w. And I'll put my plus c at the end. So I'll multiply the 1/4 through, and that gives us 3/8 x plus 1/16, and u we said was, what did you say u was? Scroll up a little bit. 8x. So this would be sine 8x. Take the 1/4 times 1/32 gives us 1/28. Sine, and we said w was 16x. So this would be 16x, and then plus c. And that's our answer. So again, we use the power reducing up here, take it down from the 4th power down to this, where we still had it squared, so then we took it again. Our u was different. First time u was 4x, this time u was 8x. And then that gets to our final answer. So let me save that. And let's look at the next problem. And let me grab a drink here. Now this is Wallace's formula. And I'm going to look it up here. I don't got this one memorized. So let me write down Wallace's formula. It says if n is odd, specifically n has got to be greater than or equal to 3, then the integral from 0 to pi over 2 of cosine to the nth power is equal to 2/3 times 4/5 times 6/7 all the way up to n minus 1 over n. And then if n is even, specifically n is greater than or equal to 2, then the integral from 0 to pi over 2 of cosine to the nth power, I didn't put a dx there, but it should be, would be 1/2, 3/4, 5/6, all the way up through n minus 1 over n times pi over 2. Oh, there we go. Now these formulas are also valid if cosine is replaced by sine. So if you have any of those in the homework. And there it is. So we're going from 0 to pi over 2, cosine of the 6 dx. Well, n is obviously even, so it's this formula on this side. And so our answer is going to be 1/2 times 3/4. Now our n is 6. It's our power. And so it's going to go up to 6 minus 1, which is 5, over 6. So it'll go up to 5/6, which actually happens to be my very next number. Now notice the pattern. The top part increases by 2, and the bottom part increases by 2. So 1, 3, 5, next one will be 7, 9, so forth. 2, 4, 6, 8. Now let's simplify this. 3 and a 6, both divided by 3. That gives me 1 there, gives me a 2 here. Multiply the top parts together. 1 times 1 times 5 is 5. And the bottom parts, 2 times 2 is 4, times 4 is 16. So our answer would be 5/16. Let's take a look at this one. We got the integral of secant squared 9x plus 4 dx. Okay, I come over here and I got secants, so I could save all of them. That wouldn't work very well. This one has a secant in it, but secant tangent, I don't even have any tangents. Actually, this one, even if I saved a secant, I'd be left with secant to the first power, because when you take one of these away from the power, it leaves you one of them. So it doesn't work at all. But we have a formula. Remember the derivative of tangent squared, or tangent. Where's that at? Derivative of tangent is secant squared. Somewhere. Derivative of tangent is secant squared. So going backwards, the integral of secant squared is tangent x. So we don't have to do that little trick here. This is just a simple u substitution. So we let u equal to 9x plus 4. Du would equal to 9 dx. So we need a 9 inside, so we'll offset it with a 1/9 out in front. Like this. And now we can replace this. This becomes secant squared u du. The 9 dx gets replaced by du. And then this becomes 1/9 tangent u plus c. And u, as we said, was 9x plus 4, so this would be tangent 9x plus 4 plus c. And that's our answer. And let's go to our next problem. Here we got secant to the fourth. And find the integral involving secant and tangent. Okay, let's take a look at this one. I don't remember this one from class. I'm not sure how much room it'll take, so let me save this. It's always kind of fun to hit these problems and you don't remember how to work it and so forth. I can't imagine working off of PowerPoints where you're just kind of reading off the problem. It's just that thrill of when you run across a problem. How in the world do you solve this? And sometimes the shortest route doesn't come to me. Sometimes it takes me a while to even see it. 5x minus 2 dx. Okay, let's go back to my save list. Actually, I see it now. Okay, I got my secants over here. If I save a secant squared, so if I save off one of those secant squareds, then I'll be left with a secant squared, which is okay. That's kind of our goal. We want to be left with the even power. So I can rewrite this as secant squared 5x minus 2 times secant squared, 5x minus 2 dx. Okay. So we said we want to save a secant squared. So we're going to save that. We won't touch that. Then it says after we save it to secant squared, then convert the rest to tangents. So we're going to convert what's this first part here into tangents. Well, recall 1 plus tangent squared is equal to secant squared. So this right here, the secant squared, I could rewrite it as 1 plus tangent squared. So let's do that. So this will be 1 plus tangent squared 5x minus 2. And then here's our save. Now we're going to want to use a distributive property. We're going to take that and multiply it times the 1 and multiply it times this. And I'll split them into separate integrals while I'm doing that. So secant squared times 1 is secant squared. Plus secant squared times tangent squared is just the two put together. So we got tangent of 5x minus 2, and I'm going to rewrite that to the second power in this manner. And then secant squared 5x minus 2 dx. Okay, so let's take a look at some substitutions here. I'm going to let what's inside the parentheses here be u. So we got u is equal to 5x minus 2. du would equal to 5 dx. So we need a 5 inside. We'll offset it with a 1/5 out in front. Now over here, well, I'll choose a different variable. I'll choose w. We let w equal to what's inside the parentheses. So w is equal to tangent 5x minus 2. dw, the derivative of tangent is secant squared. So this would be secant squared of 5x minus 2. But it's a chain rule, since we have more than a single x here. So we'll multiply times the derivative of what's inside the parentheses, which is 5. And then we'll add on dx. So this needs an extra 5 inside, so we'll offset it with a 1/5 out in front. Getting there. So now we're ready for our substitution. So this one over here, the 5 dx gets replaced by du, and then this becomes secant squared u du. On this one, we're going to replace the tangent 5x minus 2 with u, so this becomes u squared du. du is the secant squared 5 and dx. Secant squared 5 dx. Secant squared 5 dx. dx secant squared 5. All that red gets replaced by dw. Of course, it'd help if I actually used the w's. Try that again. This would be w squared dw. Okay. Now remember, the derivative of tangent is secant squared, so the integral of secant squared is tangent. So that's going to be tangent u plus 1/5. Add 1 to our power, divide by our new power. So we've got 1/3 w to the third plus c. Plug the u back in. U we said was 5x minus 2. And over here, 1/5 times 1/3 is 1/15. Plug in the w. On this one, we said w was tangent 5x minus 2. And that's our answer. You could put the 3 between the tangent and 5x minus 2 on this second part, but that's essentially it. So let me save that. Time for my tablet to blow up. Okay, let's look at our next problem. Okay, so we got tangent to the 5th of 9x dx. Okay, so let's come over here. And we got tangent to the 5th. Now there's nothing here, nothing here, nothing here. Now here, that's a possibility, but I would also need a secant. But I might actually get the secant. I mean, actually, the only choice is this is the only one with a tangent in it. So let's save a tangent, and then convert the rest to secants. Okay. So we got our tangent to the 4th, 9x, and here's our tangent of 9x. So again, that's going to be one part of our save. Hopefully we'll have another secant that we can tie in with that. Now recall, from our Pythagorean identities, 1 plus tangent squared is equal to secant squared. So this first part here, tangent to the 4th, I could rewrite that as tangent squared times tangent squared. And here's our save part. Right there. Okay. So this right here, to solve for tangent squared, take the 1 over to the right side. So we got tangent squared is equal to secant squared minus 1. So we're going to replace these tangent squareds here with secant squared minus 1. So that's secant squared minus 1. And this one's secant squared minus 1. And here's our save. Right there. And let me shift myself. Sitting too long in the same position. Oh, there we go. Okay, now I'm going to multiply those together. Secant squared times secant squared is secant to the 4th. Secant squared times negative 1 is negative secant squared. Negative 1 times secant squared is negative secant squared. And negative 1 times negative 1 is a positive 1. Which gives us secant to the 4th minus secant squared is negative 2 secant squared plus 1. then tangent dx. Again, this is our save part, so don't lose track of that. Well, let's multiply that through using the distributive property. So take tangent times this, tangent times that, and tangent times that. So that would give us secant to the fourth, 9x, tangent 9x, minus 2 secant squared 9x, tangent 9x, plus tangent 9x. Then dx here at the end. Well, the blue is what we're saving. Well, that one we don't need to save because it's by itself. But what I need along with it is a secant. So let's split this off and put a secant with that. So this is going to be secant 9x to the third power. And I'll save a secant. And a tangent. So now we got two parts we've saved off. On this one, we have minus 2, and I got secant 9x, and here's secant 9x, tangent 9x. This is our save part. Then this part here is tangent 9x and dx. Okay. Let me split them in separate integrals. Long problems. Okay. So this is secant 9x to the third, secant 9x tangent 9x dx, minus, put 2 out in front, and then we got the integral of secant 9x the first, and then secant 9x tangent 9x dx, plus, and then the integral of tangent 9x dx. And let me put the save part in blue again. That's save, and that's save. Now both of these, the first and second integral, are going to share the same u substitution. So u is going to equal to secant 9x. Now the derivative of secant, and this is why it works, derivative of secant is secant tangent. So we'd have secant x, or secant 9x, tangent 9x dx. And actually I didn't mean to put that dx first. So this is a chain rule. Since we got more than a single x here, you have to multiply it times more than a single x here, we have to multiply it times the derivative of that, which is 9. And then dx. Well, they have everything except for the 9, so we're going to offset it by putting a 1/9 out in front, and we'll put a 9 inside. So that's secant 9x to the third, 9 secant 9x tangent 9x dx, and I'll put a 1/9 out in front here, and 2 times 1/9 is 2/9, and this is secant 9x to the first, and 9 in here, secant 9x plus tangent 9x dx. Now this one over here, this would be, let's say w is 9x, dw would equal to 9 dx. So again, we need a 1/9 out in front, and a 9 inside. Never-ending section. Maybe I've picked too many problems for it. So tangent 9x, and then 9 dx inside. Okay. So this right here, we replace secant 9x with u. So this becomes the integral of u to the third, and all that becomes du minus 2/9. This is u to the first. This is du plus 1/9. And this becomes 9x is w, so that becomes the integral of tangent w dw. Okay, that still shows that. Okay. So this becomes add 1 to our power divided by our new power. So that's 1/4 u to the fourth minus 2/9 times add 1 to your power divided by your new power. So 1/2 u squared. Now the integral of tangent is equal to negative natural log of the absolute value of cosine. Like that, and then our plus c. So it gives us 1/36, and u in this problem we said was secant, 9x. So this becomes secant to the fourth, 9x. Here the 2's cancel, we got minus 1/9, and this becomes secant squared, 9x. The negative goes out in front, so we got negative 1/9 natural log of the absolute value of cosine of w, which was 9x, and plus c. And that's our answer. So let me save that. There we go. And let's look at the next problem. And I'm going to grab a drink here. So let's look at this one. 10. Get the integral of tangent to the fifth power of 8x minus 1, then secant to the fourth of 8x minus 1 dx. Okay, come over here. Tangent and secant. Tangent to the fifth and secant to the fourth. Those wouldn't be, maybe this one. This actually might work pretty good. Secant tangent, if I saved a secant and tangent out of that, if I saved a secant, that'd leave me secant to the third. That won't work at all. Again, we're looking for being left with an even power after we save. So if I save secant squared, I come over here, save secant squared here, that'll leave me secant squared. That's perfect. So this become tangent to the fifth, 8x minus 1, secant squared, 8x minus 1, and secant squared, 8x minus 1. Again, this is our save. Now, our steps say to convert the rest of tangents. So the secant squared here I want to convert, and let me write it over here, even though you've seen it over and over. This is our Pythagorean identity. It says 1 plus tangent squared is equal to secant squared, which means this secant squared right here we can rewrite as 1 plus tangent squared. So we'll have tangent to the fifth, 8x minus 1, times 1 plus tangent squared, 8x minus 1, and then times secant squared, 8x minus 1 dx. Now again, the secant squared is the one we're saving. These are all in terms of tangent squareds now, so I'll just multiply these together. I'll take the tangent to the fifth times 1 and times tangent squared. So that'll give us tangent to the fifth, 8x minus 1, plus tangent to the 7th, 8x minus 1. Since these are the same, tangent to the 5th times tangent squared gives you tangent to the 7th. And then secant squared over here. And again, that's our save. I want to rewrite these. This will be tangent 8x minus 1 to the 5th power. And this will be tangent 8x minus 1 to the 7th power. Like that. And again, that's what we're saving. Okay, so now if I let u equal to tangent 8x minus 1, du, the derivative of tangent is secant squared. So this would be secant squared 8x minus 1. But since this is the chain rule, we have to multiply it, since it's more than just a single x here, we have to multiply it times the derivative of what's inside the parentheses, which is 8. So we need 8 inside there, and we'll offset it with a 1/8 out in front. Now I think you've seen enough of those, I won't actually put it in there, but you know, 1/8 here and 8 inside. So then this becomes 1/8. That becomes u to the 5th plus u to the 7th du. Add 1 to our power, divide by our new power. So that's 1/6 u to the 6th plus 1/8 u to the 8th plus c, which gives us 1 over, I'll multiply the 1/8 through, 1/48, and u we said was tangent. So that's tangent to the 6 of 8x minus 1. And 1/8 times 1/8 there gives us 1/64th. Tangent to the 8th power of 8x minus 1 plus c. And that's our answer. Next problem. This one should be fairly straightforward. I shouldn't need a lot of space for it, but then again, let me save it. Okay, so we got cosine 4x. Problem is this 11. Cosine 4x and cosine negative 2x. Try that again. Now we got a formula that'll help us with this. Recall cosine u, cosine v, this is our product to sum formulas from trig, is 1/2 cosine u minus v plus cosine of u plus v. Well, in this particular problem, this would be u and this would be v. So I can rewrite this integral as 1/2 cosine of u minus v. So 4x minus a negative 2x. And then plus cosine of u plus v. So I got 4x plus a negative 2x, or just 4x minus 2x dx. So then this becomes, actually the 1/2 I can put out in front, so I don't have to worry about it. This becomes cosine, negative negative becomes positive, 4x plus 2x is 6x. And here 4x minus 2x gives us 2x dx. Let me split those into separate integrals. So that'd be cosine 6x dx plus 1/2 cosine 2x dx. Let this be u, so du would equal to 6 dx. Let this be w, so dw would equal to 2 dx. So So we need a 6 inside this one. We need a 2 inside this one, so we'll offset it with the numbers out in front. So we've got 1/2 times 1/6, and then 6 cosine 6x dx. On this one, we need a 2 inside, so we'll offset it with the 1/2 out in front. And we got cosine 2x, and then 2 dx. So this becomes 1/12 cosine u du plus 1/4 cosine w dw. Now the integral of cosine is sine, so this will be 1/12 sine u plus 1/4 sine w plus c. On this one we said u is 6x, so this will be 1/12 sine 6x. And on this one we said w was 2x, so this will be 1/4 sine 2x plus c. And that'd be our answer. And let's look at our next problem. This one's another one of those formulas. Let's see, sine negative 3x, and then cosine 5x, and dx. Okay. Now recall, we have sine u cosine v is equal to 1/2 sine of u plus v plus sine of u minus v. So this right here becomes, this is our u, and this is our v. So this becomes the integral of 1/2 sine u plus v, so we got negative 3x plus 5x, plus sine of u minus v, so we got negative 3x minus 5x dx. Well, the 1/2 is going to come out in front, and then this becomes sine of 2x plus sine of negative 8x dx. To begin with, the negative here we can bring out in front like that. And I'm going to split the reason why is because it's an odd function. Sine, cosecant, tangent, cotangent are all odd. If you got a negative inside, you can put it out in front. Now let's split these up into separate integrals. So we've got 1/2 sine 2x dx minus 1/2 sine 8x dx. So here u would equal to 2x, du would equal to 2 dx. Here w would equal to 8x, dw would be 8 dx. Now I'm not going to show all the steps here. Basically we needed 2 inside, so we'll offset with a 1/2 out in front. And then this becomes sine u du minus, we need an 8 inside, so we'll offset with a 1/8 out in front. And this becomes sine w dw. So that gives us 1/4. The integral of sine is negative cosine, so that's negative cosine u, minus 1/16, and the integral of sine is again negative cosine, so that's negative cosine w, plus c. Put negatives out in front, so I got negative 1/4 cosine of u was 2x. Put negative out in front here, becomes a positive 1/16 cosine of w, and w was 8x, and then plus c. And that's our answer. So save that. And time for my tablet to blow up. And let's look at our next problem. These get into the cotangents. I'm going to grab a drink here. Cotangents and cosecants. So here we have the integral of cotangent to the 9th of x and cosecant squared of x dx. Okay, what do we want to save? We could save a cosecant squared. Let's see if that helps us. Yeah, that's perfect. So we'll save this. And we're going to rewrite this one as cotangent x to the 9th power. Now the reason why we do that is because the derivative of cotangent over here is equal to negative cosecant squared. So again, that's why we're saving it. So u is going to equal to cotangent x. Du will be a negative cosecant squared x dx. So we just need negative out in front. And then this needs to be a negative cosecant squared, like that. Now we can do our u substitution. So this becomes u to the 9th du. Add 1 to our power, divide by our new power, plus c. And u we said was cotangent, so this is cotangent to the 10th power of x. And that would be our answer. And I bet I have room for another one on here, hopefully. So let's look at this one. So we got cotangent to the 5th of x, cosecant to the 3rd of x dx. Now, before we saved a cosecant squared. Over here, if I save a cosecant squared, that's going to leave me cosecant to the 1st power. We can't have that, so that one doesn't work. So come over here, we're going to save a cosecant and a cotangent. We'll use this one. Okay, so I'm going to split these up. This is cotangent to the 4th. This is cosecant squared. And we're going to save a cosecant cotangent over here. So that's our save. Cosecant cotangent, convert the rest to cosecants. So this is already cosecant, so we have to work with cotangent to the 4th. Now first thing I'll do is rewrite that as cotangent squared times cotangent squared. Cosecant squared, and then the save part, cosecant cotangent dx. Now we got our Pythagorean identity, so we can convert the cotangent squared to cosecant squared. Remember, 1 plus cotangent squared is equal to cosecant squared. So these are cotangent squareds, so I'm going to take the 1 over to the right side, and cotangent squared is equal to cosecant squared minus 1. So this becomes cosecant squared minus 1 times cosecant squared minus 1 times cosecant squared times cosecant cotangent dx. I'm going to quit showing so many steps because I'm getting kind of tired of these. You probably are too. So I'll multiply these together and then multiply times this. Well, cosecant squared times cosecant squared is cosecant to the fourth times this. Again, we add the powers. That gives us cosecant to the sixth. Of course, now watch me screw it up. Now here we got cosecant squared times negative 1. That's negative cosecant squared. Negative 1 times cosecant squared is negative 2 cosecant squared. And negative 2 cosecant squared times cosecant squared is negative 2 cosecant to the fourth. Negative 1 times negative 1 is positive 1 times cosecant squared gives us cosecant squared. And then our save part. First problems, I was trying to show all the steps I didn't show in class. Kind of skipped over some of them. So if you need to see them, they were online. But enough is enough. I can't do any more of all the steps. Of course, that's a good way not to screw up, is to show the steps. And I'll rewrite these. This is cosecant x to the sixth power. This is cosecant to the fourth power. And this is cosecant to the second power. And then our save part. Like that. And now we'll do our u substitution. U is equal to cosecant x. The derivative of cosecant is negative cosecant x cotangent x dx. Well, we have the cosecant squared, we have the cotangent, we have the dx. We don't have the negative. So we offset it with the negative out in front, and that would put a negative inside. And then these would become u to the sixth minus 2u to the fourth plus u squared du. Add 1 to our power, divide by our new power. So we got 1/7 u to the seventh minus 2/5 u to the fifth plus 1/3 u to the third plus c. The negative we're going to carry through. And then we'll plug in our cosecant for the u. So we've got negative 1/7 cosecant to the seventh plus 2/5 cosecant to the fifth. Then negative changes this to negative 1/3 cosecant to the third x plus c. And let me save that. Ready for the next problem. I think I'll raise my window. Let's see, get some air. Oh. There we go. Okay, let's look at our next problem. Were we really on that one? Yeah, I guess so. So close. So here we got the integral of cotangent to the fifth x, cosecant x here, and dx. No way I can save a cosecant squared, probably not easily. I'm going to try to go with this one. And the reason why I'm saying that is it says convert the rest to cosecants. That would work well with a cosecant downstairs here. Well, so this right here would be cotangent squared, cotangent squared. Let me put the x in there. Cotangent squared, cotangent squared, cotangent over cosecant dx. And then the cotangent squared, even though you have it down from before, recall the 1 plus cotangent squared is equal to cosecant squared. So if I take the 1 over, cotangent squared is equal to cosecant squared minus 1. So this becomes, right here, cosecant squared minus 1 times cosecant squared minus 1 over cosecant. And I'll take cotangent and put it to the side here. I won't worry about the x's right now. I'm getting lazy. That's my save. Okay. Now multiply these together. And I'll split I'll go ahead and just multiply them. So that gives us cosecant to the 4th minus 2 cosecant squared plus 1 over cosecant. And here's our save. Split these into separate fractions. And that becomes cosecant to the 4th over cosecant minus 2 cosecant squared over cosecant plus 1 over cosecant, cotangent dx. Now if you got cosecant to the 4th over cosecant, this is like the first power. 4 minus 1 is 3. So this gives us cosecant to the 3rd and this is 2 minus 1. That gives us just a cosecant. And this one I can take up on top if I wanted to. And this would be cosecant to the negative 1 power. I don't think that would help me though, because I need another cosecant out of that. Let's leave it in that form. Like that. Well, let's split these up. So I have cosecant to the 3rd and cotangent dx minus, I'll put 2 out in front, and we got cosecant cotangent dx plus, and this would be cotangent over cosecant dx. Okay, back here. We needed a cosecant cotangent. So for this one, I'm going to rewrite this one as cosecant x, and I'll put the x back in there now. And this will be cosecant x, cotangent x, dx. This is our save part. Now this next one, cosecant cotangent. If I saved that, I'd have nothing left. But we have a one of our not identities, one of our formulas. I'm getting tired. One of our formulas says the integral of cosecant cotangent is negative cosecant. So this would be negative 2 times negative cosecant x. And this one over here, cotangent is cosine x over sine x. And cosecant is 1 over sine x dx. Okay, so this one here would be u is equal to cosecant x. Du would be negative cosecant x, cotangent x, dx. So that means we need a negative inside, so we need negative out in front. And this would become u squared du inside. Negative times a negative is positive. We've got 2 cosecant x. Now over here, since they both have a sign in the denominator, those can cancel. We got cosine over 1 or just cosine. And this one, add 1 to our power, divide by our new power, plus 2 cosecant x. The integral of cosine is sine, so that would be sine x plus c. And u we said was cosecant, so we plug that back in. We got negative 1/3 cosecant to the 3rd x plus 2 cosecant x plus sine x plus c. And that's our answer. And let me save that, and then we're down to the last problem. Curious how long this movie will be. This will probably be a new record. I meant to release it at the box office. Sure, it'd be a big hit. They'd come from miles around. Let's see, sine squared over cosine of the fourth. I did this one in class, but I'm not sure if I remember it. Okay, sine squared over cosine squared, I'll split it up, times 1 over cosine squared. Now if I do that, then this is tangent squared, and this would be secant squared. And now it works out pretty good, because in one of these we said we save a secant squared and rewrite everything else in terms of tangents. So I'm going to use form 3. So I'm going to rewrite this as tangent x to the second power. And here's our save part. So we let u equal to what's inside the parentheses, which is tangent. And derivative of tangent is secant squared, dx. So this becomes the integral of u squared du. Add 1 to your power, divide by your new power, plus c, and u is tangent. So I plug that in, and we get that. And that's our answer. And the last problem. There we go. Stop the recorders. 1 hour and 27 minutes, that's all? Seems like I've been doing these forever. Not that I haven't been having fun, but the headphones are becoming uncomfortable in my head. My fat little head. Okay. And then end the other recorder.